This is lesson 2.4 on perimeter of polygons. Before watching the recording, please make sure that you have a graph sheet of paper or you're on the next graph sheet of paper in your notebook. Along with that, you need a pencil, a straight edge or a ruler, and perhaps some different colored pens as well. If you need to pause the recording to get those items, please do so now. And now I'm going to continue. Please make sure that your page is set up the way I have it here in the video. So today's date should be written at the top left-hand corner of the page, along with 2.4. We'll first start off with a few definitions. If you can think about putting these definitions in your own words before I jot them down, please go ahead and do that as well. And the first definition we'll deal with will be polygon, because we'll be dealing with polygons in the next few lessons. So a polygon, if you remember from previous years, it's any closed figure. Made up of straight sides. Or I should say straight edges. So remember, anything like a circle can't be classified as a polygon. A triangle would be your minimum size of polygon because it's a closed figure made up of 3 straight edges. The next definition we'll look at will be regular polygon, and that'll be a focus for some of this lesson. So a regular polygon is any closed figure made up of edges where all the sides are equal. So again, a regular polygon deals with any closed figure made up of edges where all of the sides are equal. I'm actually going to take my highlighter and highlight those 2 definitions. Okay, so those are definitions having to deal with polygons, and then the focus of this lesson will be perimeter. And you can box this definition out too. So the perimeter, as you would have watched in the Math 6 Spy Guys video, perimeter refers to the distance around the outside of an object. And think to yourself, what units of measurement do we usually deal with when we're looking at perimeter? Oftentimes we have meters, we have kilometers, we have centimeters, or we have millimeters. So those are often the units of measurement when we're dealing with perimeter. I'm going to box out this definition because this is the focus of the lesson. And what you're going to be learning about today is how to formally calculate the perimeter of polygons, specifically regular polygons when you're using a formula. So make sure you jot those definitions down. Now I'm going to continue. So the first example of a regular polygon we'll deal with will be this. So make sure you're taking your ruler or your straight edge and copy this down. So, and I'm going to use a different colored pen here. I'm going to say this side is 3 centimeters. And then this and this. Now, when you have markings like this, indicating, this indicates equal sides. So notice that all of these sides are equal. This is what's known as an equilateral triangle. And this was mentioned in the previous lesson when we were dealing with angles in a triangle. Remember, in an equilateral triangle, all the sides are equal and all the angles are equal. So this is one type of regular polygon because all of the sides are equal and it's made up of straight edges in a closed figure. So this is one type of regular polygon. Now, typically in the past, think to yourself, how would you have figured out the perimeter of this triangle? Well, you're given the dimension of one side, which is 3 centimeters. Because you have these hash marks, this indicates that all of the sides are equal. Therefore, this side has to be 3 centimeters and this side has to be 3 centimeters. So probably what you've done in the past to calculate the perimeter is you've added up the sides. So you have 3 centimeters plus 3 centimeters plus 3 centimeters because you want to calculate the distance around the outside of the figure. That will give you 9 centimeters. Okay, that is your answer. However, there is a more formal way to calculate it. And what we do is we try to apply a general formula to calculate the perimeter of a regular polygon. Now, this one we'll be working with now will just be specific for the perimeter of equilateral triangles. So how we start that off is we're going to call it P equals, and P in cursive. Now, we assign a variable or we assign a letter to the unknown side because 3 centimeters, it won't always be 3 centimeters. It could be 5 centimeters, it could be 6 centimeters, it could be 10 centimeters, it could be 100 meters. We don't know. Since that's our unknown, we're going to call that L for length, length of side, okay? And remember, that can be any number. It stands for anything. That's why we give it a variable. So we're going to call that L. Now, what is the shortest way to calculate this? Well, really what we're doing is if in an equilateral triangle, all the sides are the same, we know that if we multiply this by 3, we're going to get the perimeter. So that's why the formula for an equilateral triangle's perimeter is going to be L times 3. So box that one out too, because that's important to know. So the formula for the perimeter of an equilateral triangle is L times 3. Now, every time you calculate the perimeter of any regular polygon where there's a formula, you have to write that down first. The next step is to substitute, and you always substitute using brackets. So note on the next line, I still rewrite P equals. Now, I'm going to substitute that for L. In this case, it's 3 centimeters. Okay, times 3. Notice I'm recopying everything on the next line, exactly in the same order as it is above. Then, P equals again. We know 3 centimeters times 3 will give us 9 centimeters. And always circle your final answer. That's how you apply a formula. First step is you need to always write the general formula. The second step is that you need to show substitution in brackets. You have to substitute that value out. And then the final step is calculate it and circle your final answer. Don't forget your units of measurement. Now, the second type of regular polygon we're going to deal with is going to be a square. So let's deal with that next. So again, this will be example number 2. Copy this down. Oops, I'm going to just undo that. And remember, none of my drawings are to scale. So I'm just telling you what the measurement is for each of them. Here. Okay, so I'm going to use a different color again, and I'm going to say this is 4 centimeters. Now remember, in a square, it's also a regular polygon. Therefore, all the sides have to be equal. So as we mentioned above, remember this hash mark here indicates that all those sides are equal to each other, okay? Because it's a square. So the square is another type of regular polygon, but remember in this case, 4 sides are equal. square. Oops, hold on one second. So a square, and I'm going to just jot down in brackets again. This is another type of regular polygon. Remember, we're dealing with regular polygons because all of the sides are equal. Okay, so in this case, now think about what is an easy way to calculate the perimeter of a square. If you look above, remember that we dealt with an equilateral triangle. You simplified finding the perimeter of an equilateral triangle looking at a formula. It typically in the past, again, you probably would have done 4 centimeters plus 4 centimeters plus 4 centimeters plus 4 centimeters, which would have given you as a perimeter 16 centimeters, right? But in this case, simplify it using the formula, and that's the expectation. How do we do that? Well, similar to above. So we're going to go P equals, now this time again, we're going to substitute and use the variable L, which stands for the length of sides, times, how many sides do you have in this case? Well, this case we have 4. So we can say that the perimeter formula for a square will always be L times 4 because there are 4 equal sides. Go ahead and substitute. So if you want to pause the recording at this point and do the work yourself and then check in afterwards, go ahead and do that. I encourage you to do that. I am going to continue. Remember, the next step is substitution. We have to substitute L. In this case, we know our length is 4 centimeters times 4. Remember, I'm recopying everything on the next line in the same order as it appears above. Now we can solve 4 centimeters times 4. P equals 16 centimeters, and then circle your final answer. Our final example will deal with the final regular polygon. There are more regular polygons beyond this, but we'll just deal with 3. Will be a hexagon. So let's do 1. So please, again, draw this out. 3. Okay, because it's a regular hexagon, again, I'm going to have the appropriate 1, 2, 3, 4, 5, 6. One side is going to be 2 centimeters. Remember, we assumed that all the sides are equal because of the hash marks. And hexagon is another type of regular polygon, so long as all the sides are equal. It's important to note that sometimes you don't have regular hexagons, so you can't apply the formula here. You can only apply the formula for a regular hexagon when all the sides are marked equal. So before I get into the formula, I want you to try and figure out the formula and solve it. Use the same process as we did above. Think of the shortcut way to solve this in terms of its perimeter. So I'm going to continue. So we're going to have and start with P, which stands for perimeter. Remember, we're going to use L again as our variable times, well, how many sides does a hexagon have? You know that it has 6 sides. So P equals L times 6 is going to be the formula for a hexagon. The formula for the perimeter of a regular hexagon. So you go ahead and substitute P equals, in this case, 2 centimeters, times 6. And then on the next line, you're going to solve that. Remember, recopy everything as it is here. You know that P is going to equal 12 centimeters, and circle your final answer. So in summary, what we've looked at is the perimeter of regular polygons in this video. What I mean by regular polygons is that all of the sides in the polygon are marked equal. In the video, we looked at an equilateral triangle. The perimeter formula for that is L times 3. Once you know the length of one side, you just multiply it by 3, and then you can find the perimeter for the whole triangle. The second example we looked at was a square. Remember that in a square there are 4 equal sides, so the perimeter formula for that is the length of one side times 4. Finally, the other example we looked at was a regular hexagon. And in a hexagon, you have 6 equal sides that are regular. So what you do is you apply the formula L times 6. You substitute L for whatever side length you have, and then you multiply it by 6. Remember that these formulas can only be applied